This is a P1 energy video looking at national and global energy resources. Now we know we've got our non-renewable energy resources, including fossil fuels, coal, oil and natural gas, and also nuclear fuel. And we have a finite supply of these. That means we have a fixed supply, we can't remake them and they will run out. And then we've got our renewable energy resources, which include biofuel, wind, hydroelectricity, geothermal, the tides, the sun and water waves. And these can be replenished as they're used. Okay, so we won't run out of those. Uses of energy resources include transport, electricity generation and heating. So those are the main uses of why we would use these particular energy resources, okay, for transport, electricity generation and heating. Now, each of these sources in turn, we don't have to know a great deal about how they work, okay? Sometimes I think it's useful to know how they work because then it helps you with the advantages and the disadvantages. The important thing is looking at advantages and disadvantages of each of the different resources. And this is likely to be an evaluate question, okay? Looking at pros and cons, where we use our subheadings to compare different resources, okay? It could be that you are asked to compare your own example of a non-renewable energy resource with your own example of a renewable energy resource for 6 marks, okay? So you write 3 marks about each, saying clearly advantages and disadvantages and stating which are pros and which are cons. So let's have a look at fossil fuels first, okay? So we can see from the picture here that we've got a boiler. Underneath here will be boiling the fossil fuel. There's water in this tank, which then gets converted to steam. The steam causes the turbine to turn, which is connected to a generator. And that's basically a coil of wire inside a magnet. And as it spins, electricity begins to flow through those wires. Okay, electricity can't be stored, has to be used straight away. And the steam then goes through the cooling towers, it's condensed back into water to go back into this tank. And the electricity goes through the national grid, which we'll talk about in another topic. What's good about fossil fuels? Well, it's actually quite cheap. The power station's already set up, so in getting the coal, oil and gas is quite cheap. So it's efficient, so we get a decent amount of electricity for what we put in and the energy used to create that electricity. And it provides most of our energy. It's very reliable because we can produce it as we need it. Okay, we call that supply on demand. So because we can't store the electricity, we need to create it as it's needed, which we call supply on demand. Disadvantages, it's non-renewable, so it will run out. These resources will run out. Produces carbon dioxide as a byproduct, which is a greenhouse gas. So it's trapping the heat, leading to global warming. There are impurities in the fossil fuels in the form of sulfur and nitrogen compounds. When these burn, they create sulfur dioxide and nitrogen oxides, which contribute to the formation of acid rain. There are high setup costs, although power stations that are set up now, we don't tend to build new power stations very often, we just use the ones that are set up now. The mining of coal scars the landscape. Oil spillages cause environmental problems. So it does look to be quite a lot of disadvantages there. Let's move on to nuclear fuel. Nuclear fuel uses nuclear fission of uranium and plutonium. We talk about nuclear fission in P4. And in that nuclear fission, energy is released as heat. And that is used in the same way as it is in a fossil fuel power station to heat that water that then turns to steam and turns the turbine. Advantages, there's no pollution to the atmosphere if it's used correctly, okay? So it's not producing the carbon dioxide, the sulfur dioxide, the nitrogen oxides. The fuel is relatively cheap, it's reliable, and we've got that supply on demand. Disadvantages, the waste from nuclear power stations is very dangerous and it's difficult to dispose of. They dispose of it, and we look at this again in P4, in thick lined concrete bunkers stored in metal containers, and then they fill it with concrete so that if that spills out, it doesn't go into the surrounding soil and water supplies. Cost of running the plant is high, and the decommissioning cost. So when we don't want to use the power station anymore, to make the area safe and to what we say decommission it, which means to get rid of all of the nuclear material, is expensive, and there is a risk of major catastrophe. And we look at the Chernobyl disaster in P4. Now let's go to our renewable fuels. So we've got biofuel. This can be anything from burning of plants, trees, and burning waste material like chicken poo. There's still a lot of energy to be taken from that. Decomposition of organic material in anaerobic digesters, so a bit of a link there to B7. Bioethanol from fermentation of sugarcane. Okay, which we also talk about in biology, and biodiesel from filtered used cooking oil. So on the back of McDonald's lorries, they say that they use all of their cooking oil as biodiesel, so they filter it and then use it in the transportation of the produce in the trucks. Advantages: renewable. Try not to use renewable as one of your advantages, because it's likely to say in the question that it is renewable already. Carbon neutral, this is an interesting point. So because the biofuel was a plant, it was photosynthesizing and taking carbon dioxide out of the atmosphere. But then when it's burned, it releases carbon dioxide, but we say because it did both, it once took it in and it once released it, we refer to it as carbon neutral, although there is a bit of debate over the balance between the amount that's taken in during photosynthesis and the amount that's released when the plant is burned. Disadvantages: land use of crop growing means that food crops will reduce and loss of habitat for animals. We see this in B7 again with deforestation. Farmers are realising that they don't want to grow crops for food because they can get more money from growing the sugarcane and making bioethanol from it. They use a lot of fertilisers to grow the crops quickly, particularly as they're not being used for food. They can justify doing it to get the biofuel quickly, and the transportation costs of moving biofuels around the country. Let's have a look at wind turbines. So wind turbines, basically, like we've got that turning turbine in the power station, we've got the wind turning a turbine, which again is connected to a generator to produce electricity. It's renewable, there's no air pollution, there's minimal running costs, and there's no permanent damage to the environment. That means that if we removed the wind turbines from the area, there would be no evidence of them having been there. Disadvantages: people say they're ugly and they're noisy. So if you have some built near your house price might go down as a result of all of these wind turbines being put there. They put them in the sea quite a lot, and people say that it spoils the view. Lots are needed to meet the demands. They're not particularly efficient. They're not particularly reliable, as we don't know when it will be windy and when it won't be, so it's not predictable. There's no ability for that supply on demand, and there's high initial costs. Let's look at hydroelectricity. Okay, this is our reservoir, and we've got a dam. We've got some pipes here with turbines going to a lower reservoir. Okay, the water flows through the turbines when you open the tap, and those turbines are connected to a generator. Again, renewable. Supply and demand is really good because there'll be several of these kind of taps and turbines across the dam, so you can maybe open one of them or four of them. There is a quick startup time. It literally is just open the tap and the water goes through the turbine. There's no air pollution, minimal running costs. It's useful in remote places, and the spare electricity, remember I said earlier that electricity can't be stored. The spare electricity can be used to pump the water back up to the top reservoir to start again. Disadvantage: high setup costs. You've got a massive dam there. It's going to damage the habitats of the animals and plants living in that area. Where the land has been flooded, the vegetation that rots releases methane and carbon dioxide, so indirectly there is release of pollutant gases to the atmosphere, and it requires a hilly area. You've got to have the gravitational potential energy of the water so that it can then flow downwards to turn those turbines. Okay, let's look at geothermal now. So this is inside the earth. There is the decay of radioactive substances in the rocks, and as they decay they release lots of energy as heat, and we have these pipes that go down under the earth, and water is pumped through those pipes, and it's pumped through cold, and when it comes out of those pipes, because it's heated by the heat from in the earth, it's very hot water, and that steam is used to turn turbines, again connected to a generator. The advantages are that it's renewable, there's no fuel required, there's no air pollution, and there's 24-hour production. It is predictable, it is reliable, it's always hot in those areas under the ground. It's only suitable in some places, and it's expensive to set up. If you had any breakages in that pipework under the ground, obviously that's going to be expensive to fix as well. Let's look now to the tides. How does it work? Water is pushed through turbines underwater, so it's kind of like wind turbines but for under the sea, and this is as the tides go in and out. It's renewable, it's predictable and reliable because the tides are predictable. There's low running costs, high power output, and no air pollution. Disadvantages: expensive setup. Tidal range varies, so in some places there'll be a big tidal range, other places a very low tidal range. It wouldn't be able to be used where the low tidal range is. Damage to the habitat and wildlife, and they look ugly because you see this dam above the water. Let's go next to the sun as an energy resource. How does it work? Generate electric currents directly from the sun. So remember, we don't need to know all the ins and outs. This is the only one that doesn't use a turbine, okay? So we generate electric currents directly from the sun. And we can see on this picture, it's on a large scale. Can be on a small scale as well. These can be used on calculators, on road signs that are the ones that just flash up as an extra sign when maybe you're going too fast in a particular area. So it's not the only road sign that's there, but it's an additional sign which, if there is no sun, you know, and that sign hasn't got the energy to work, it's not the end of the world, but it's a nice added extra. And for ticket machines, so car park tickets, things like that, okay? So things that run on very low amounts of electricity. There's no pollution, it's reliable, very reliable in sunny countries, okay? So these can be used in areas where we know it's sunny a lot of the time. It can be used maybe where, again, the area isn't on the national grid, it's a remote area, so they can rely on the sun. Disadvantages: cannot increase power output with demand, okay? So once you've got the power output, if we need more, you know, the solar panels, they're just always there, okay? It's not like we turn them on and off. And it's not useful at night or on cloudy days. High initial costs also. Let's look at the last energy resource, and this is water waves, okay? So these, we find these in Scotland in remote areas that aren't on the national grid, and they are big concrete blocks. And we can see here that there's this chamber, okay? Sometimes ducks can get stuck in here and they can't get out. But as the waves go up and down, it moves air through the turbine that again is connected to the generator. It's renewable, there's no air pollution, it's good in remote places, not supplied by the national grid, and there are minimal running costs. Lots disadvantage: lots needed around the coastline, ugly and a hazard to boats, not good for the marine environment, unreliable, and high setup costs. The reason they're unreliable is because for the waves we need it to be windy, and if it's not windy we might not get waves, and therefore we don't have that reliable source. But as the wave goes up, it pushes air through the turbine, and as the wave goes down, it pulls air back through the turbine. So the turbine turns in both scenarios, when the water goes up and when the water goes down. Remember, when we do these questions where they use the word evaluate, we must state advantages and disadvantages, and we can use a grid setup. Okay, so we could do a subheading water waves and then a grid of advantages and disadvantages. Okay, hope you found that useful. Thank you. This is a P1 energy video looking at the equation for elastic potential energy. Now this is the one of the equations that you will be given on the equation sheet in the exam. We've got 0.5, so half, times a spring constant in newtons per metre, times the extension squared. Okay, now it's extension, not total length. So we've got it in a formula triangle, and we assume that the limit of proportionality has not been exceeded. So you stretch an elastic band and it stretches in this uniform way, this way that kind of gives us this positive correlation on a graph. And then after a while you keep pulling it and you put more and more force into it, but it doesn't stretch anymore. Okay, where that graph kind of tails off and it stops being a straight line graph, kind of curves off at the top, we've reached the limit of proportionality. So all of this calculation is used within that limit of proportionality. So spring constant kind of gives us an indication of how stretchy a spring or an elastic band is. Okay, and the question says, what is the spring constant of a spring with an elastic potential energy of 30,000 joules when extended by 4.7 meters, and it wants the answer to 3 significant figures. So what I did is I took the equation. I know I want spring constant, so I can rearrange using my formula triangle. Then I'm going to do the elastic potential energy divided by half the multiplied by extension squared. Okay, so I've rewritten that equation. I've put in my information. Okay, and it's really important to remember that we do this multiplying at the bottom first. So you can see I've converted this equation by working out 4.7 squared, times that by half, I get 9.4. Okay, then I do my 30,000. It's nice to do things in steps, show the examiner you know what you're doing, stop yourself getting confused. And when I do that 30,000 divided by 9.4, I get a spring constant of 3,191 newtons per metre. I go back to the question and it asks for my answer to 3 significant figures. So I've changed my answer to 3,190 newtons per metre. Hope you found that useful. Thank you.